Okay, so we are going to get started today. Yesterday we created expressions. Our objective for the day is you are going to solve today algebra expressions by me giving you a variable to work with. So the expressions are already done today. Now you have to put numbers in place of those letters or those variables. So how can we use patterns to show relationships? Well, check out these tickets here. These are tickets to a theater. If we look at a pattern, is this pattern going to help us solve the problem? Well, if we follow that pattern just like we did in our problem of the day today, we should be able to figure out what we don't know. Shauna wanted to buy tickets for this concert for her and for some of her friends. So what's the total cost of all of the tickets? Can we do that? Why can't we? What information are we missing? Oh, we do though. Look, it's right there. That we know. Right here. What don't we know? Cole? We have no idea how many friends she has. So, what operation are we going to use? Well, we will use algebra. You're right. We can use multiplication. So, if we know how much one ticket costs, we can find out how many tickets will cost depending on how many friends she has. So, we can take that $4 and we can use the letter T for the amount of friends that we don't know are coming. So she makes a table. Now in math, sometimes we call these input-output tables because if you put a number in, a different number comes out. So the number of tickets that she is going to purchase depends on how many friends she has. So we can look for a pattern in this data. The lowest number we could put in the table, we could always start with 1. One ticket is how much? $4, okay? Well, if one ticket is $4, how much would 2 tickets be? $8. How about 3 tickets? $12. How about 4 tickets? How about 5? Okay, so if she tells us how many friends, we can easily, by looking at this table, figure that out, right? Well, that's what we're going to do today. We are going to use patterns to find numbers. So let's take a look at this first example. Megan and Travis have the same birthday, but Travis is 6 years older. So in the table, M is Megan's age. We don't know how old she is, but M plus 6 is Travis's age. So let's complete this table. If M is 3, what would M plus 6 be? So we can take that 3 and we can slide it over to where the M is. And what would that be, Erin? 9. Okay, now let's take a 5, slide it over. What would M plus 6 be then? 11. Ooh, now they're going to try to trick us. Now we got to work backwards. What number would we slide over here so that number plus 6 equals 14? Ooh, a little trickier. Sarah says 8. Is 8 plus 6 14? Yeah, how did you do that? Did you just try a few numbers? Okay, trial and error works. Is there another way you could have solved that, Dathan? It is going in a pattern. Not really. This makes it a little tougher because right. Okay, so did she just say 8 should go here? Okay, well, from 9 to 11 is 2, but from 11 to 14 is 3. From 3 to 5 is 2, but from 5 to 8 is 3. So there's maybe a pattern of add 2, add 3, add 4, maybe something like that. That's a possibility. Whoops. Absolutely, that would be one way to solve it. Thank you. Okay, so I'm going to try to fix this here. All right, so I have some examples today. We have n times 6. Now you can write it like this, or you can write it with a multiply sign in the middle. Either way is okay. Okay, so I want you to tell me what would be my answer if n equals 7. What would be my answer? Dathan? Thank you. What if n equaled 9? Caden? 54. Okay, today on your assignment, they're going to give you two variables, and you'll have to give two answers. One for the first variable they give, and one for the second. Okay, we're going to do two answers for each of these. So starting with problem number 1, this is problem number 2. So problem number 1, the variable is 21. What would the answer be? Answer A, answer B. Answer A, Aaron says 15. 21 minus 6 is 15. Okay, now let's use the other variable. Slide the 33 over there. 33 minus 6. It's okay today if you need scratch paper to do this off to the side. That's okay. Some of you can probably do this in your head. Like Darius. 27. 27 would be our second answer. Okay, let's move on to the second problem. Starting with the variable of 21. What would the first answer be? (21 minus 8). Sky? I'm going to show you a good trick. If you don't really need to do this off to the side. There's no need to do this. Instead, we could start at the number 18 and count up to 21. 3, exactly, 3. Okay, now let's slide the 33 down. Now our variable's 33. N minus 18 would be what? This is a tougher one. I don't know if you can do this one in your head. Well, you're close. Dathan? 33 minus 18. 3 minus 8, can't do it. 15. Not 25, but 15. Yep. Answer B is 15. Good job. We're going to do a few more before you guys practice. Okay, here we go. Using this one here, 40 divided by n. Let's start with this variable, 10. Aaron? 4. 40 minus 10 is 4. Now let's slide this variable down. 40 divided by 4. Alexis? 40 divided by 4. How many 4s are there in 40? If you're not good at dividing, you can always turn it backwards. 4 times what gives us 40? 10. Good job. Okay, now let's move over to the next problem. This is another way to write a division expression. 20 divided by n. I don't know why that little mark is right there. 20 divided by n. So let's move our first variable down, the 10. 20 divided by 10. Aaron? Now let's move our next variable down. 20 divided by 4. Aiden? Good work. Okay, now, you guys can take out your iPads and open up to a blank screen. Nope, no stylus today. Okay, here's what I would like you to write on your board. You have two variables to use. The first time n is going to equal 3. The second time n will equal 7. So get those up there. Now the expression we have to solve for is n6. Another way to write that is, I'm going to put or 6n. When they're squeezed together like that, what operation does that mean? Help me, help me. Multiplication. Multiplication, that's right. Okay, go ahead. Nice thick line so that I can read. Okay. First answer. Eileen, can you please put N6? Now, slide this one down in place of the N. What will your first answer be? Pull out your chart if you need it. Now, is it true that if I slide this 3 down in place of N that it means 36? No, it means 3 times 6. Eileen says 18. Good work. How about the next one? We need to write a little faster, people. Natasha. 42. 7 times 6 is 42. Good work. All right. Next one. Clear your board. $2.2. And 1.2. A little thicker, or a little less thick, I think, Eileen. Tough to fit all of it in otherwise. Okay, so here is my problem. What's the most important thing when we add and subtract decimals? Line up the decimal. Does this number have a decimal, the 7? It really doesn't. But, you guys, 7 means the same thing as 7.0. Keep that in mind as you're adding. Okay, anybody want to share their first answer? I bet a lot of you were able to do this in your head. Emma? Oh, you're so close, except you forgot a really important part of the number. Not 92. Thank you. 9.2. I put 2.2 under it. Added them up. Okay? How about the next one? 1.2. Alan? The answer would be 8.2. All right, next one. This time it's only one variable, and it's oops. Here we go. Solve for that. Kiara? 1.2. Our answer is 1.2. We slid the 1.5 down, we subtracted, and that's what we got. Good work. Good work. Okay, you guys ready for a little bit of a challenge now? Okay, take a look at this one. Let's see if you can do it. Start with the 11, slide it down. This is tougher. I will be honest and tell you there's none this hard today, but I'd like to see if you could do it. My class kept saying, make them harder, so I did. I kept making them harder and harder. We'll see if you can get this one.